Let's begin. Ready? Ready? Okay. So if you guys have looked on your resource sheet, which is a pink piece of paper, I have a white one because it's the original. Like I said, there's a list of the content that we are covering. But what I want to talk about today is this back page here that outlined the assessment requirements for the electrolytic cells and the galvanic cells. So it's broken up into the Achieve, Merit, and Excellence. It's really useful for you guys to look at this while you're studying, so that way you know what needs to get done. So you guys are aware of how I'm going to organize this assessment. I'm going to break it into two parts. So we're going to assess first the electrolytic cell, and then I'll teach the galvanic, and then we'll assess the galvanic. The reason why I'm doing it this way is to avoid confusion, so you don't confuse these two cells. And also it's good just to break up the assessment and treat it kind of more like a portfolio of work. For this assessment, you need to pass both cells in order to pass overall, but there'll be multiple opportunities for you guys to show that evidence. Just like I did last year, if you guys remember, we did like basically the first attempt, you get a grade, and a second attempt, and I take the better of the two grades. The other thing that you have to be mindful of is that for excellence, you need to do a compare and contrast between these two cells. If you're not aiming for excellence, you don't need to write that comparison. Are we good so far? All right, so let's start with what you need to have for the electrolytic cells for just the electrolytic. So what's going to happen is on the assessment, you'll be told that this is part one, and it's the electrolytic. The other thing I will tell you or provide for you is a diagram, and it's the diagram of an electrolytic cell. So the diagram of an electrolytic cell will have one beaker, two electrodes going in, the battery, and then a solution. And in fact, I am very, very nice on this assessment that I also show you guys little bubbles coming off of one. And I show like a little metal kind of sheath going over the other one. So that's basically what you're going to get as like a standard image on the assessment. The other thing you're going to get on the assessment is a description of what reaction you are doing. So in this case, or I should say in all cases, what I will give you is molten ionic solids. I won't give you aqueous ones because with the aqueous ones, there's an extra level of difficulty, which is the water that you have to worry about. So in order to avoid that level of complication, I make them all molten. There's nothing in the assessment criteria that say you have to be able to distinguish whether or not water is being oxidized or reduced, so that's why I don't include it. So if we look at the practice problems I've given you, I'll do the first one, which is the silver chloride, and show you how to write it up. So we have the electrolysis of molten silver chloride. So again, molten is your hint to say there's no water there. And in fact, I will also give you the formula as well. I will also give you the observation. So in this case, we have bubbles. Of a pale green gas, and we have a gray metal deposit. So everything that I've written in black is essentially what you would get on a piece of paper. We're good so far. Easy peasy. All right, so let me tell you what you need to do for the achieved, and basically what you need to do to pass. So the first thing you need to do is you need to figure out what's happening with the reaction. So I would take your ionic compound, which is this guy here, and I would break it up into its ions. So that'd be step number 1. And I'll put this in, I'm just trying to think what color I don't use. I wonder if yellow will show up. So we're thinking about steps. Step 1 is to, can you guys see the yellow okay? Yeah, you can. Break apart ionic compound to its ions. Now, let's say you don't know what the ions are supposed to be or what their charges are supposed to be. You are going to use your resource sheet. So make a note. Use resource sheet. If you don't know the ions charge. Are we good with that so far? All right. Ready for step 2? Yeah? So step number 2. Now on this assessment, you don't need to write down any of the stuff that I'm writing in yellow. It's only the red that I need for the assessment. The yellow is just showing you how I'm processing. So yellow equals processing. You don't need to write it. AKA their instructions for you. Yeah? The stuff in red is what you need for the achieved. Things are gonna get a little squish. All right. My second step is to go from ions to elements. So if I have silver, Ag, if I am not sure what the product is supposed to be, again, use your resource sheet. Now there's 2 hints for that. Either you look to see where silver is, and you go, oh, there's Ag plus and there's Ag. Or I can look at the redox couple and look for silver and the silver metal. So that's the other hint I can use. I could also look at a periodic table and look for it. So Ag should become a plus, Ag plus to Ag. And I should have Cl minus. If I'm not sure what it's going to go to, again, look at the resource sheet, see where else I see Cl. I see Cl here. I also see Cl, hopefully, on my list. If not, there it is, Cl minus Cl2. So I can use the list to help me figure things out. Actually, identifying the products isn't achieved, my bad. So I'll put that in red. Use the resource sheet. Are we good so far? Yeah? All right, now what we are thinking about is oxidation and reduction and trying to assign the 2. whichever is my cation is going to get reduced. So cation, the positive charge, is going to be the reduction. And this negative one, the anion, negative, is going to be my oxidation. So break up your ions. You're always going to have cation is oxidation. Sorry, cation is reduction. Anion is oxidation. Keep going. All right. So what I now need to do is I need to identify what's going on here and tie things together and figure out which is the oxidant, or sorry, which is the cathode and which is the anode. What I notice here is that I have something solid forming, and that's that gray metal deposit. And what I have on this side are my bubbles. And I notice that my bubbles are a pale green. Now, two things I can think about. First off, when I have silver going to the silver metal, we can again look at our list and I see that Ag is solid and it has a metallic luster, so that helps hint to me that that's going to be my solid. Also, when I look over here, Cl2 is a gas and it's a pale green. So you see how things match up with the resource sheet. So if I'm trying to figure out which one's which, this solid half must be this reaction here. So I would start labeling my electrodes. This electrode is my, yeah. So this electrode on my right is my cathode. And remember, your cathode has reduction. And your Ag plus is becoming Ag. Yeah, because you're showing what your product and reactants are. To be fair, you had them over here. Actually, I'll probably change that back to yellow. I don't like my color coding. I know you guys are going to hate it. All right. So on my other side then, this is my anode. Anode always has oxidation. And in this case, we are going from the chloride to the chlorine gas. I'm going to change this back to yellow because I think it's better as yellow. Grab a piece of paper and roll over it. Don't like that. There's the reason why I didn't do it the first time. That's my little budget twink. I'm too lazy to go get my twink. There we go, fixed it. Nothing happened. You see nothing. Huh? Cool. Like I said, yellow was just my processing to show you guys how I was doing my steps. All right, so yeah, like I said, I have labeled cathode and anode. I've labeled what I have started with and what I have made. The other thing you need to then do for the achieved is just your definitions for redox. So for reduction, I would say there's two choices. You can either say that it's gained electrons. I'm leaving a space for when we go up to the merit. The other option for the achieved is you tell me if it's gained or lost, if it's increased or decreased in oxidation numbers. Or you say that it's increased oxidation numbers, which we'll talk about later. The other thing you then need to do is the second half, which is looking at the oxidation. So oxidation, what has happened to the electrons? You lost electrons. I'm going to make some more space over here. Lost electrons. Again, I'm leaving space for the specific number of electrons, so that's getting us up to merit. Or you could say what? Sorry, this should say decreased. Increased oxidation numbers. I had a mistake here. Sorry, guys. Decreased. Or you could say increased oxidation numbers. So that's not anything specific. Those are just generic definitions. Yeah? Are we good so far? All right. Last thing you need to say for me for an achieved is that this is a non-spontaneous reaction, or it requires energy. Is non-spontaneous, or you can tell me that it requires energy. So the stuff in the red is all I need for the achieved. So the trickiest thing to get this, so basically, let me backtrack. This bit, and this bit, that's just memorized on the piece of paper. The only thing you need to then do for the achieved is take your ionic compound, split it apart, and figure out what is it producing from that, and then assigning oxidation and reduction. Whatever the cation is, it's going to be reduced. Whatever the anion is, it's going to be oxidized. That's all you got to do for the achieved. I'll just leave it at there for that because I don't want to overwhelm people. And I want to give you guys a chance just to practice the achieve stuff before I dive into the merit. Sound good? All right, what questions do you have? You okay? All right, so what I will now put on the board are these practice problems for you guys to do. Like I said, we've done the silver chloride. I'm going to cross this out because I want to talk to you guys about what you want to do. So that doesn't need to be there. I'll give you the formulas as well. AgCl, aluminium, AlF3, ZnBr2, magnesium iodide is MgI2, lead is PbCl2. Just be mindful those twos are supposed to be subscripts. This program doesn't allow me to do that. MnBr2. Tin is Sn. And I can't remember if it's a positive 3 or positive 2. Okay. There you go. You got some practice problems to do. We've already done number 1, so I'll cross that off the list. So you have 7 more to do. I'll make it a bit bigger. Make it bigger. Okay. There you go. I'll pause the recording. Just to help you guys out, I want to point out that you have the redox couple on the left-hand side of your resource sheet. What I suggest you do is look for the ion that you are currently starting off with. So, for example, fluorine's right here. Sorry, fluoride's right there. And the ion for electrolysis is always going to be on the right-hand side of that pair. And you're going in that direction to form the element, because we're going from ion to element. So if you have fluoride, you're going to fluorine. And if I was looking for aluminium, oh, wait, sorry, I'm lying. If you're going in that direction, you're going in your reduction. and you're going this direction for oxidation. This way reduction, that way oxidation. No, I lie, other way. Sorry. This way's reduction, that way's oxidation. My brain, last period. So if you're going to the left, that's your oxidation half. If you're going to the right, that's your reduction half. So I see the fluorines over here on my right. It's going to the left. That's my oxidation. If I look for aluminium, the ion, we're starting with the ion. We notice it's going that way now. Reduction. Better? Hopefully.